Or I get an idea. And action. All right, so questions on chapter 3. I believe. Bailey, you hinted at having some earlier.
Yeah, on page 45, with the acceleration on inclined plane, I don't understand how to do that. It's on page 45.
Page 45.
Yep.
Okay. And, sorry, you were saying again?
The acceleration on inclined planes.
Right?
I don't understand how to do that. Like, I don't understand what he's trying to say.
All right.
I mean, is that important to know?
The general concept there is beginning physics classes love the inclined plane. Some angle theta. Now, for this class, we don't have to go into the trig of it, but the general concept. So what he's just dealing with is, what my quick reading of it right now is that it's just talking about the concept of acceleration. So if I have an object in free fall, so the only force acting on it is its weight, then the acceleration will be the acceleration due to gravity. So acceleration is just the acceleration due to gravity. Shorthand notation for the sentence I just said. Let's assume we're on some strange planet, because I want to make the math easier, where g is equal to 10 meters per second squared. So if I start this thing off, if I look at the velocity in meters per second, and time in seconds, at time is equal to 0 seconds, the velocity is 0. We're just taking an object and dropping it. After 1 second, what he's getting towards, if acceleration is 10 meters per second squared, that means the acceleration 10 meters per second squared, that's the same as 10 meters per second, which means the velocity is going to change by 10 meters per second every second. Now, since I'm dealing with a vector here, we need direction. So positive direction up or positive direction down?
Positive down.
Okay? So if we make positive down, my acceleration is 10 meters per second squared, so my acceleration vector is positive 10 meters per second squared. Because acceleration, so resulting in free fall, acceleration is downwards. So after 1 second, acceleration also being change in velocity over change in time, which tells me after each second, my velocity changes by 10 meters per second. So after 1 second, it's going 10 meters per second. After 2 seconds,
20.
Sorry.
20.
Okay.
Meters per second.
After 3 seconds,
30.
and so on, until it hits the ground. Now, on Earth, it's not 10, it's 9.8. On Mars, I think it's 3.7 meters per second squared. On the Moon, 1.6 meters per second squared-ish. All these are rough values. 9.8 is not, it's not a constant on the surface of the Earth. It's approximately 9.8 meters per second squared around the surface.
Is the velocity at which it hits the Earth like the same amount of normal force the Earth will exert upon it?
No, the normal force involved depends upon how fast it stops once it hits the ground. So if I hit soft ground, it takes longer to stop it because ground is going to give way. Not as much normal force is needed to stop it. But if it hits hard pavement, it's going to stop very quickly and it requires a great deal of normal force to stop it. So more information would have to be given. So that's free fall. Now, on the inclined plane, we can have some control over what the acceleration is. The acceleration, if we assume that down the ramp is positive, and this is an example of why we don't always want positive directions to be in the classic math ways. we can control the acceleration by the angle. So assume I have some angle where my acceleration is 2 meters per second squared. Since I made down positive, acceleration's in that direction. So if I had, well, that's the same as my velocity, that's the change in velocity over change in time, which is 2 meters per second, which means my velocity will change by 2 meters per second every second. So if I start out at rest, and then I let go, after 1 second, how fast will I be going now?
Wait, ask the question again?
2 meters per second.
It'd be 2 meters per second. If I have this at an incline such that my acceleration is 2 meters per second squared, then after every second, my velocity is changed by 2 meters per second. So that would be 2, then
6.
so on.
Okay, so you just took this equation, velocity equals acceleration times time. You just moved time over and then velocity divided by time equals acceleration.
That works too. Yeah,
Okay.
they're related.
Okay.
All right. Questions on this, because I'm about to make it look more complicated. All right, let's make it look more complicated. Let's take the object, instead of dropping it, I'm going to throw it in the air. I'm going to throw it upwards. Let's make down still positive, because why not? So that time is 0, my initial velocity. So if I initially throw it up at, so thrown upward, initially at 6 meters per second. Yes?
Would it be negative 6 meters per second?
The velocity would be. I was just giving you a speed right here.
Okay.
Upward tells you direction. I said down was positive, so therefore this would be negative 6 meters per second. After 1 second, what is my velocity?
0? Or
Not 0.
6?
Negative 12.
What's the gravity?
Negative 12.
Negative 6?
No.
It'd just be 6.
6.
All right, let's think about what this acceleration is telling us. The change in velocity, oh, we're here. Change in velocity is 10 meters per second every second. So if my change is 10 meters per second,
It's going to be 4 meters per second.
the change is 10. It's going to be negative 6 plus 10. All the acceleration is telling us is, if we know the number, in 1 second, how much is the velocity going to change? If instead I said it was thrown downwards at 6 meters per second, then my time, at time 0 in seconds, my velocity in meters per second. So if it's initially thrown downwards at 6 meters per second, after 1 second, how fast is it going?
16.
I think somebody said it. Oops, I want to repeat units. 16. So it's just saying the change in velocity, the rate at which it changes. Yeah, the way he worded this is he talked about the velocity acquired is acceleration times time, and yeah, I'll buy that. I think change in velocity works better for me, but he apparently liked the wording velocity acquired. Questions on this? Other questions on chapter 3 right now? Penelope?
I can understand kind of how to move forward from this kind of stuff, but I don't know how to, I guess, go backwards, like when it's asking for, well, specifically I'm thinking of the master set. for chapter 3, where it has some questions where it's like, okay, it gives you some of the information, and then it's like, find this, and find this, and find this, and find this, and I don't know how to find those.
Did you look at the sample problems I gave? There are 6 sample problems I gave in the, I suspect it's in the supplemental material.
Okay.
I'd be glad to work through one. I was just wondering if you had gotten to those and were confused or just hadn't seen those yet.
I don't think I've seen them.
Yeah, can we,
Pardon?
for like, maybe just for me, like, in future reference, can we probably do like one word problem to have like a bunch of questions after?
Yep. Yep. So a car is moving along a straight road. The straight road is telling me it's a one-dimensional problem. So it's just either going to be, all it can do is move one direction or the opposite direction. No verbs. It is initially going at positive 15 meters per second. The fact that I put a plus sign in here is telling, it should be indicating that I'm giving you a velocity instead of just a speed. If I just put 15 meters per second, you know, I'd have to tell you at least some information about whether that's positive, the velocities, whether it's moving in the positive direction or the negative direction to start with. If the acceleration is negative 5 meters per second squared, after 10 seconds, what is the velocity? Displacement? Or why not? Distance? Let's not do that one yet. Let's do average velocity. Distance. Average speed. I don't remember what else was in the master set problem, but this should cover a number of things. All right, so it starts out at 15 meters per second. After 10 seconds, it's going, we're trying to figure out what is the velocity after 10 seconds. If you recall from, I'm hoping you can recall from the video, that the sign for velocity tells you in which direction it's moving. Ariana.
Negative 35 miles per second squared.
I suspect, no, I would take off 2 points for that answer.
For what reason?
Units wrong. What would be the
Oh,
units?
meters per second squared.
-2.
It's not squared.
You corrected
Oh,
one.
meters per second?
Yeah, just meters per second. Now, if you're thinking miles per second and you put M there by itself, I wouldn't know what you're thinking on that, but M is just meters. All right, so let's go through that. There's 2 ways of looking at it. One is the chart method, and chart method works fine, just like we just did. So let's just start out that way, and then we will branch into more sophisticated ways. So at time 0, it's going 15, and then 1, 2, 3, 4, trouble with this is if I threw in 42 seconds, then yeah, that's a whole lot of writing you're going to be doing it this way. So it's the acceleration is -5 meters per second squared, otherwise known as -5 meters per second. What is the velocity after 1 second? Keep going.
5. 0.
All right.
-5.
Okay.
10.
And then so on. 15. Let's see, that is there. -20, -25, -30, -35. All right. So that the change is -5 every single time. Technically, there are 2 more words I should throw in here. Is uniform and -5 meters per second squared. Okay. Questions about this way of finding the velocity at 10 seconds before I do a different way?
So this is how you find velocity?
This is one way.
Okay.
The other way, acceleration is change in velocity over change in time. So I can find my change in velocity, or using Hewitt's wording, velocity acquired. My change in velocity is just acceleration times time. So that's -5 meters per second squared times how much time took place? 10 seconds. So my change in velocity is -50 meters per second. Well, I started at 15, my change is -50. So 15 plus -50 is -35. A slightly more sophisticated way of doing the same thing. On a test, traditionally, I will see both from different students. Generally, a student doesn't do both. All right. Averaging. What is the average velocity? All right, let's do it the old-fashioned way, and then we'll work to a simpler method. I have a bunch of numbers here. How do I find an average? And how many numbers do I have here? Thank you. The most common mistake I see students make in this technique is divide by 10. There are 11 numbers, because we have 0 here. So if you add them all up and divide by 11, what do you get? And by the way, the technique right there of adding them all up and dividing by how many you have, it works if acceleration is constant, and these are even time increments. So every 1 second, satisfy that. Someone's about to tell me what the average is.
-10. -10.
Meters per second. Anyone confirm?
Doubting my math skills?
Or as soon as she said -10, you thought, oh, well, she's probably right.
So you got that by adding all those numbers up and about 11?
Yep. I'm assuming that's what you did. Bill, I got -10. As the Russian proverb says, trust but verify.
Yeah, -10.
All right. So we have two people with negative 10. It should be negative 10. All right. So what's special about 1 second increments? I listed them up by 1 second, but is there anything special about 1 second increments? Is that more special than 2 second increments? Suppose I got rid of every other one, got rid of all the odd ones. Now how many numbers do I have?
6.
And if you add them up and divide by 6, what do you get?
The same.
We'd be in trouble if we got different answers. Yeah. What's special about 2 second increments? Suppose I want to do 5 second increments. So let's see, at 5 seconds, this was at negative 10. Now I got 3 numbers. If I add those 3 numbers up and divide by 3, I'm going to bet I get negative 10. What's special about 5 second increments? Why not just do a 10 second increment? I can just add those 2 numbers up in my head. That's get negative 20, divide by 2. I get negative 10 again. So if acceleration is uniform, and this is the key here, as long as we have constant acceleration, all I have to do is just take the first and the last one and average those 2 numbers. I don't have to add them all up. And again, on a test, I will see evidence of some students will average the first and the last one. Some students will add them all up and divide by however many numbers there are on the test. Should get the same answer. If you do it both ways, you get different answers. Then I'm willing to bet at least one of those is wrong. Anyway, negative 10 meters per second. This was negative 35 meters per second. Questions to hear before we talk about displacement? All right. What is displacement?